Hello guys, welcome to all. This is the Electrical Walnut channel and this is me Neeraj Burma. So in this video lecture, we will going to discuss about another chapter. This is the book of VK Mehta, Rohit Mehta, and this book is for preparation of government services just like BTech, engineering services exam and get another examination. So now as we know we had finished our first chapter, so now this is the second chapter. This name is DC circuits. So now it's really glad for me to cover one chapter earlier, and now we are in the session of second video lecture. Second chapter video lecture. So this is the second chapter of first video lecture, in which firstly we have to read about the chapter overview, because I think if you start any chapter, then chapter overview is really important to make interest in any chapter. So firstly we have to just go through direct currents. What is direct current? So there are two type of current, as we know. One is AC and one is DC. So in this video lecture we have to cover up direct current. The chapter name is DC circuit. So you know very well, according to this chapter we have to only cover about DCs. DC means direct current. So what is direct current is given on a first point. So now we have to just read this. They are given definition. The direct current that always flow in a one direction. A direct current is that current which flow in a one direction is called direct current. The current supplied by cell or battery in a or DC generator is known as direct current, right? So those current which flow in a one direction is known as direct current, and it is supplied by cell or battery or DC generator, right? So this is known as direct current. I mean, if I simply relate with graph, then suppose this is a graph, then this is a graph of direct current. I mean, only single direction, only one direction. But if I'm talking about alternating current, then alternating current is in this form. I mean, sinusoidal form. Sometimes its magnitude is high and sometimes its magnitude is low. So here their magnitude is zero and here is maximum. So this is not in one direction. Sometimes it's goes to apex level and sometimes it goes to lowest level. So this is alternating current and this is direct current. So first of all, I am not here to give the brief explanation about the chapter. I am here to just give the overview, and I am just uploading the videos because of recording to competitive exam. So as we know, in a competitive exam it's not going to ask to you theory or anything related to solid information about the definition what is direct current or whatever that. So only we have to just go through a smart way of learning. What? A smart way of learning how to cover our chapter within a, as much as less time, because you know very well, to conserve time is really crucial for us, because we are a student and we should have to know the value of time, right? Value of time. So first of all, as we know, as I mentioned, what is direct current. So now the second point is direct, DC circuit is what? The DC circuit are that circuits, the closed path followed by direct current is called DC circuit. So as you know, this is a DC circuit. So first of all, what is battery and what is cell? So cell is this is, suppose this is, if only one combination is given of this one, then this is known as cell, but the combination of more cell is known as battery. So here you found the combination of two cell is here, so this is known as battery. So above you had know very well, direct current is produced by battery or DC generator, so this is a battery, battery, right? So this is a battery and this is a closed path, and this is a bulb. So when we connect the bulb by applying a battery, this is a voltage, then bulb will glow. Then this circuit is known as DC circuit. But suppose here if we use a alternative current, then this is known as AC circuit. So here we use a direct current, so this is known as DC circuit. So now let's come on the third point. What is third point? The third point means resistance in series. So what is resistance in series? The number of resistance are said be connected in a series if same current flow through the each resistor, right? I mean, only we have to just know one more important thing in what's happening in a series when resistor is connected. So when resistor are connected in series, then the same current flow through each resistor. It is really important to know, because I think there are lots of time this question is asked in a competitive exam. What's happening in a series? I mean, current is constant or voltage is constant. So we should have to know, in series current is constant to each resistor. And after deriving the formula, we got when there are lots of resistance are connected in a series, then R total means total resistance equal to what? We add all one in a this way, I mean algebraic sum, then we find the total resistance R1 plus R2 plus R3 and so on. If there are lots of resistance, then we can add like that R4, R5, R6 and so on, right? So this is a resistance in series. Now we have given here given some point regarding to series of resistance. So as we know, this is a formula. If there are lots of resistance, to find out the total resistance. So when we divided total resistance by V square, then you know a power equal to what? V square by P square by V square by R, right? This is the formula, V square by R, I mean power. So I think if you not watch the earlier video, then I think you're not well aware about what is the formula of power, because in previous video lecture I think I had cover up the formula of power. So what are you doing, guys? If you are not watched the earlier videos, then for making your interest and making the concentration I can say a focus in this video lecture, then obviously you have to go on a previous lecture. So yeah, as I mentioned, power equal to V square by R. So here we can convert this formula into power. So total power equal to what? P1 plus P2 plus P3, and this is for power. And now it's conductance. Conductance means what? A reciprocal of resistance is known as conductance. So in this same way we can derive in this way. Total conductance equal to what? 1 upon total conductance equal to 1 upon conductance 1 plus 1 upon conductance 2 plus and so on. So this is the formula for conductance. First of all, we should have to know why all the formula are given for, first of all, power, and after that conductance, because it's really important. It's really important regarding to your what? Recording to your competitive exam. So don't try to skip any formulas, because it's really important regarding to your numerical and formula. And now it's given the two diagram. One is for series, and this is for series, and this is for parallel. So now in series, a resistance is connected one end to end connection, right? End to end connection. This is a series, and you see very well, this is a series connection. R1 is connected after R2 and after R3 with a single, I can say, battery. This is a battery, this is known as cell, because this is the combination of cell is known as battery. And this is a parallel combination. You can see very easily, this is a parallel combination. There is no end to end connection, but here is end to end connection. So this is a parallel and this is a series. And one more thing have I want to add here. In series connection, current is same to each resistance, but here voltage is same on each resistance, right? So now we have to just go on a fourth point, and fourth point is what? Resistors in parallel. The number of resistors are said to be connected in parallel if the voltage across, what I mentioned just I think 1 minute ago, voltage across each resistance is same. Voltage across each resistance is same in a parallel. So after deriving this formula of parallel, the total resistance for in a parallel combination, we found 1 upon RT equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on, if there is more number of resistance are given in your questions. So same thing apply here, as we know the power formula of power. So when we multiply, or when we multiply, we can, I mean, assume this is the equation 1. So when we multiply by equation 1 into V square, then V square by RT equal to what? Power. So total power equal to what? P1 plus P2 plus P3 and so on, right? So this is the formula for power, as you know here what I told. P power total equal to P1 plus P2 plus P3, because this is in a parallel. But what's happened for a series combination, P total equal to 1 upon P1 plus 1 upon P2. So we have just keep in our mind, because both the formula is looking similar. This is for series and this is for parallel. So we should have to just concentrate and give our 100% to learn the formula, because both the formula is looking similar. And say, so now it's a second point, and second point for conductance. So conductance is same like earlier, what how we had found the conductance in series. So this is for parallel. Total conductance equal to what? Conductance 1 plus conductance 2 plus and so on, right? So this is the way we can find the power and conductance in a series and parallel combination. So now fifth point, and fifth point is really important. Suppose here, let's suppose for two resistor in parallel. So in this diagram it's mentioned there are two resistor, R1 and R2, right? R1 and R2 are connected in a parallel. So total resistance, how we calculated? As we know the formula, R total equal to what? 1 upon R1 plus 1 upon R2. So when we solve this formula, then ahead we find R1 into R2 by taking LCM, plus in numerator R1 plus R2, right? So by solving all this, I mean this calculation, to make calculation easy, we learn the trick. I mean upper we can product, and I mean denominator we can sum, then we find the total resistance. So in a parallel, if we have to find the total resistance, then we can use this formula to find out, I mean very quickly, because in a competition it's really important to solve as taken less time, because in a competition it's really need to time consuming for us. So this is how we had covered also this session, I mean this video lecture of second chapter. This is the second chapter and this is circuit. So I hope you had if you watch the video at last the end, then obviously if you have any confusion, then please comment me in a comment box. And if you have any suggestion which I have to just improve in my video lecture, then please comment on that, because if you give me your feedback, then obviously I would like to work on that to make my videos as much as, I mean I am giving my best, but obviously I know very well there is lots of lacking point. So if you just work on to just inform me on my lacking point, then I would like to say you thank you. So lastly I would like to say thank you.